All right, this is exam 1 for Physics 101, the online section, fall 2013. Since 1967, the standard definition for the second has been based on the characteristic frequency, the cesium atom, which formula is dimensionally consistent with an expression yielding a value for velocity. Remember, velocity is meters per second, and so I want to know which of these gives me meters per second. Well, I have Vx squared, that's meters per second, times x squared, which is meters squared, that's meters cubed per second, so it's not that one. AT, that's meters per second squared, times second. That is meters per second, so that gives me, cancels there and there, so that is the right answer. I can go and do these other two, meters per second, 1 over second squared, that's meters per second cubed, so that's not it. And then V squared, which is meters squared per second squared, times 1 over seconds, that's meters squared per seconds cubed, so that's not the answer either. All right, calculate these, keeping only significant figures. Okay, well here, I'm going to keep the lowest number of decimal places. So I'm going to have 2 decimal places, so that would be 0.86 times 4.4 times 10 to the third, or I can write it as 4,400. So here I have two sig figs for both of these, so I'm going to just keep 2 sig figs, so the answer will be B, 3,800. Cereal box has these dimensions. If there are 3.2 feet per meter, what is the volume of the box in cubic feet? So I have 0.19 times 0.28 times 0.07. If I do that operation, I get 0.19. I get 0.0037, that's cubic meters, and that's keeping the lowest number of sig figs. They all have 2 sig figs, so I'll just keep 2 sig figs. And then I want to convert that into cubic feet. I know that in 1 meter, there are 3.28 feet. However, I have to cube this term, and so that's 0.0037 times 3.28 cubed. 0.13 cubic feet. That is C for number 4. Apartment has 1,100 square feet of floor space. What is the approximate volume of the apartment? All right, so we need to know what is the height of the apartment. And let's just say that it's 10 feet. That the height is 10 feet. And so 10 times 1,100, that's 11,000 cubic feet, or 10 to the 4 cubic feet. So number 5 is B. All right, which of these is consistent with this expression, y equals x squared? Let's see, if I double x, then y quadruple. Oh, that is correct, actually. That was actually straight from the concept test. If y doubles, x does not quadruple. If y is greater than x, not necessarily. So you have y equal x squared. Like, for example, I could have x equal 0.1, and that would make y 0.01, so there y would not be greater than x. If I double x, say I make double x, I get 4 here, so D is not correct. A is the correct answer. The truck moves 70 meters east, and 120 meters west. So notice then that this difference here is 50. And then east again, a distance of 90 meters. What is the truck's resultant displacement? So if this distance is 50 meters, that means that this distance is 40 meters from the original location, which is right there. So it's 40 meters in the positive x direction, or in the easterly direction, which is A for number 7. What is the acceleration of this object? Is it positive, negative, or 0? Or impossible to tell. Well, notice that the slope of this is decreasing. So I have a decreasing speed, slowing down. And it is decreasing speed. It's also a negative velocity. Because it's decreasing, that means that the acceleration is opposite the direction of the velocity. That means that it is A, positive. It is A, positive. If you drop a very bouncy ball, it falls and then hits the floor and bounces right back up to you. Which of the following represents the velocity? So I have a ball, I drop it, goes down, bounces off the floor, and then comes back up again. This is the situation. Here, notice I have a big initial negative velocity. So I have negative velocity that's big, and then that is small. In fact, it's 0 at the very beginning, and then it gradually increases as you go down. Small negative velocity that increases in the negative direction. Then at this point, it goes from having a big negative velocity to having a big positive velocity. So I go from here to here at the bounce, and then as it comes up, it slows down, but in the positive direction. Also notice that the slope of this part is always negative, and it's actually always negative 9.8, because the slope is the acceleration. So the slope there and there is negative, it doesn't switch. So like, for example, that one would not be relevant. This is like an object where you're throwing like that. All right, this graph represents the position of a particle over 5 seconds. What is the instantaneous velocity at t equal 2 seconds? That's right here. Just find the slope of this line. The rise is -6, and the run is 1.5. And so rise over run is -6 over 1.5. That's equal to -4 meters per second. That is C for number 10. For the above graph, what is the average acceleration? Or excuse me, that should say average velocity from t equal 3 to 5 seconds. So I want to know the average velocity between here and here. This is my initial velocity, initial position. This is my final position. So to find average velocity, it's going to be 0 minus -2 divided by the change in time, which is 2 seconds. That's 1 meter per second. So the answer for number 11 is B. All right, number 12. A ball is pushed with an initial velocity of 4.0 meters per second. And a constant acceleration of, of 1.6 meters per second squared. It reaches the bottom of the hill in 8 seconds. What is the ball's velocity at the bottom of the hill? So we just say V equals V naught plus AT. That's 4. We get 16.8 or 17 meters per second. So that is D for number 12. Displacement is which of these following types? Displacement is a vector quantity, so 13 is B. Vector in the xy plane has a magnitude of 25 and an x component of 12, so we'll cite this, 25 on magnitude. The x component is 12. I want to know what is this angle. Let's say the cosine of theta equals adjacent, that's 12 over 25. So theta we get 61 degrees, so it's A. It's 14. Following are two vectors, which represents the sum B minus A equals C. So I write B first, and then the negative of A. Look like that. So C will look like that. So that is D. Identical guns fire identical bullets horizontally at the same speed from the same height, one on the Earth and one on the Moon. Which of the following 3 statements is or are true? The horizontal distance traveled by the bullet is greater for the Moon. That's true. Remember, if a particle follows a path like this on the Earth, it's going to follow a path like this on the Moon because it falls at a slower rate. The flight time is less for the bullet on the Earth. That is also true because it falls at a lesser rate. It's in the air for longer. And the velocity of the bullets at impact are the same. That is not true. The object on Earth has a bigger velocity because it falls at a faster rate at minus 9.8 meters per second squared versus the moon, which is minus 1.6 meters per second squared. So that's going to be C for number 16. Stone is thrown horizontally and follows a path x, y, z. Direction of the acceleration vector of the stone at point y, is which of these vectors? The acceleration is always downward. The acceleration vector is always downward. So that answer is C for number 17. All right, airplane is shown with altitude of a half kilometer. It's the same as 500 meters. Speed of 42 meters per second. At what distance D should it release a heavy bomb to hit the target X? Our first thing is we want to find the time required for a bomb to go from here to here. All right, so I know Y is 42. Or excuse me, that's V naught X. I know that V naught Y equals 0. And I know that my Y final is negative 500 meters. And that my acceleration in the negative Y direction is negative 9.8 meters per second squared. So I can say then that Y equals V naught Y T plus 1/2 AYT squared. So that's negative 500 equals V naught Y is 0, so this whole term goes away. 1/2 minus 9.8. Oh, I see. I said just take it as 10. We'll just take it as 10 here. It doesn't really matter what you do. You'll discern the right answer. Negative 10 meters per second squared. And then I want to know T. So that's negative 500 divided by negative 5, should be T squared, equals T squared. Take the square root of both sides. And we find that T is the square root of 100, which is 10 seconds. So it takes 10 seconds to fall from here to there, to where it actually hits at point X. And so now I want to know what D is. I know that X is equal to V naught X times T. So X is the same as D here. V naught X is 42 meters per second. T is 10 seconds. So D is going to be 420 meters. The distance D. Let's see, that was number 18. Yeah, so number 18 is D. All right, object is shot from the back of a railroad flat car moving at 40 kilometers per hour on a straight horizontal road. The launcher is aimed upward, perpendicular to the bed of the flat car. If it's moving at a constant velocity, which it is, it's going to fall on the flat car. We had a concept test question like that. If we know an object is moving at constant velocity, we may assume that the net force rather on the object is 0. If it's moving at constant velocity, that means the acceleration equals 0. And that means that the sum of the forces is ma, that is the net force, is equal to 0. Two ropes are attached to a 40-kilogram object. The first applies 25, the second 40. If the ropes are pulled in opposite directions, what is the magnitude? So I have this block or whatever, and I have these two forces. This is 40 kilograms. One's 40 newtons, one's 25 newtons. So the net force is 40 minus 25, which is 15 newtons. And now I want to know the acceleration. Acceleration is F over m. That's going to be 15 newtons over 40 kilograms. I get 0.38. That's B for number 21. Almost done here. What can you say about the force of gravity acting on a feather or a stone? The force of gravity, obviously the stone is heavier, right? So it has a greater force of gravity. That's D. You step on the accelerator of your car and in 10 seconds increase the speed from 10 to 30 meters per second. What is the force? Well, first we need to find the acceleration. We know that V is equal to V naught plus AT. So we can solve this for the acceleration. I go from 10 to 30, so I have 30 minus 10. It's 20 over 10, or 2 meters per second squared. That's my acceleration. My mass is 1,000. So my net force is ma which is 1,000 times 2 or 2,000 newtons. That's A. Inertia of a body tends to cause the body to resist any change in motion. Two forces act on a 6-kilogram object. One of the forces is 10 newtons. The object accelerates at 2 meters per second squared. What is the greatest possible magnitude of the other force? All right. So if it accelerates at 2 meters per second squared, that means that F equals ma, 6 kilograms. It means I have 12 newtons. That means that the greatest possible magnitude of the other force is 22 newtons. That would give us forces that look like this. Right? Otherwise, the least possible force would look like this. I would have 10 newtons in this direction and 2 newtons in that direction. So it could be anywhere between 2 and 22 newtons in order to give us a net force of 12 newtons.